Hey there guys, PC Guy here, and this is mostly going to be a talking head video focused on screens. This is because, well, we have mostly focused on good equipment, good PC components, nice GPUs and CPUs that help you bring your FPS up. But to actually enjoy that FPS and see it on your screen, you need to have a screen capable of handling those frame rates, which, well, unless you are a bit more on the enthusiast side of thing, you probably don't. Most people, and the majority, and that does not mean that it's a majority of you guys watching this channel or channels like this, because people that watch this kind of channels usually are a bit more on the enthusiast side of things. Most people just tend to stick to the standard 1080p 60 Hz refresh rate. That's the most common right now. It's also the one of the cheaper ones. Obviously, there's worse even out there, but that's kind of the standard that most people use on their PC these days. Think of the refresh rate of a screen as being the FPS that a screen is able to display. It's not as linear as this, but it does have some caveats, and the way it works is some different synchronization technologies, which I will list in a second, but that is pretty much the baseline of it. First things first, because the whole refresh rate and sync conversation is kind of a longer one. I'll start with the basics and work my way to that. So for resolution, for example, most screens, for example, I am on a 1080p monitor that is 1920 by 1080. That means that there are 1080 pixels vertically along the screen, and there is 1920 horizontally along the top of the screen. What does this mean? It means that whether your screen is 22 inch, 27 inch, whatever, that is the amount of pixels that it has. What influence does this have in terms of size versus resolution? If you have a smaller screen with the same amount of pixels as a bigger screen, the smaller screen is going to have more pixel density, so more pixels per square centimeter or square inch, whatever you want to call it. So what this will influence is you will have a bigger detail because each pixel will be smaller. Imagine that you are drawing a circle made out of squares. If you have big squares, you're going to see the blocks as the circle goes. If you have small squares, it's going to appear more round at first sight, even though the squares are still squares, obviously, but it's going to appear more like a circle. It's a crude analogy, but that's what you get when your screen is showing you shapes and stuff when you are in games or applications or what. The pixels are square, and if the shapes are round, if you have poor pixel density or a poor resolution, then you will see it as a blocky thing, kind of like the old games from back in the day. This is where the higher resolutions come into play. By cramming more pixels into the same space, you get, well, better quality of picture, better visual detail. If you have a 22-inch with 1080p and a 22-inch with 1440p, the 1441 will definitely have a better visual quality. However, it will also be taking a bigger toll on your equipment to actually run and achieve the same frame rates that you have on your 1080p. This is why if you are running on 1440p, you will need a better graphics card than on 1080, and if you're running on 4K resolution, for example, you need an even better one to achieve the same level of frames. Same goes for the CPU. Actually, the opposite goes for the CPU. When you are running at lower frame rates, your graphics card is not under as much of a load, so the load falls on the CPU to actually prepare more frames for the graphics card because the card processes them faster. While you're running on 4K, it's the GPU that does most of the work because it takes longer to process the frames, it has more pixels, then the CPU does not need to work as hard because it has more time to prepare them while the graphic card is busy doing the actual rendering. As far as type of the screen, not all screens are created equally. There are different types of screens that, well, have different manufacturing techniques, and they have their own pros and cons, and none of them are perfect, but some are more suitable for some types of use than others. For example, I'll just give you the names of the types of screens and displays that there are out there currently in the market. It's mostly TN, IPS, and VA. Now, TN panels are usually used for competitive gaming because they support very high refresh rates, low response times, and low input lag, and pretty high resolutions. However, their viewing angles and color accuracy is very poor compared to the others. Doesn't mean that it's horrible, but compared to the other options, it is poor in terms of the color fidelity of what you see on your screen. So for a competitive gamer that you just want quick response time, a nice refresh rate, this is probably the ideal choice. However, if you are, for example, a content creator that values the color accuracy and all that sort of thing, not so much. IPS is pretty much on the other end of the spectrum. It has very good color reproduction, very good viewing angle, so if you're looking at an angle, you won't see that glare on your screen or the screen darkening and all that sort of thing. However, they solve these issues at the cost of lower refresh rate and worse response time. So if you want to enjoy a nice clear picture, for example, if you are into very immersive games, or if you're a content creator that values how your picture actually looks and you want your colors to be as accurate as possible, because what you are seeing does not mean that it is what other people will be seeing on their screens, depending on your screen qualities, then IPS is probably what you are looking for. VA is a bit of a middle ground, a bit of a strange middle ground. It has better refresh rates than IPS and better contrast. However, the viewing angles and the color reproduction are worse than IPS, although still being better than TN. However, the response times are a bit worse because they are slower than IPS, even slower than IPS, and also, well, much slower than TN. So that is, if you are playing, if you are a gamer and you value response time and refresh rate, then it's definitely not the screen for you. We come to the big boogeyman in the room, the refresh rates and the synchronization between your GPU and your system and the monitor and what you see. Most screens on the cheaper variant have no sync technology. There are several sync technologies out there, like G-Sync from NVIDIA, which makes your screens a bit more expensive if you have that, and FreeSync, for example, from AMD, which has open source and it's not really AMD specific, and usually the monitors that you can find with them are a bit cheaper. G-Sync is certified by NVIDIA, which is why the screens are more expensive. FreeSync is, like I said, open source. Now, why are these important? On the cheaper end of the spectrum, like I said, screens do not have either of those two, and you're reliant on the open source VSync. Now, what VSync does, and it's mostly prevalent, is let's say your screen is 60 FPS. If you have VSync on and you have more than 60, VSync is on and it caps the FPS to 6 and you are seeing at 50 FPS. This is important because if your screen is running at 60 FPS, VSync is off, and you are seeing 120 FPS in your game counter, you might experience issues on your screen like tearing, artifacts, that sort of thing. So VSync is important to prevent that. However, the issue with you not having a variable refresh rate monitor is that if your FPS in the game drops under the refresh rate of the monitor, for example, if you drop to the 58, 57 FPS for a second, or for more than a second, then you will not be seeing 60, you will not be seeing those 57 FPS on your screen, on your 60 Hz screen. You will be seeing 30 because it will half it, it will cut it down to half of the screen's refresh rate in order to actually display it. It will not give you the in-between values, it will have it. So if you're experiencing 57, you will see 30 on your screen. If you're experiencing 29, it will have it again and you'll see 15. So in that case, not having a variable refresh rate monitor can really hurt your experience as a gamer. What happens when you have G-Sync and FreeSync is that your screens usually have a range of frequency that they can display. For example, let's say that your screen can display between 20 and 144. So at any value between 20 and 144, you will see exactly on your screen the same refresh rate as you see in the game. It is not a matter of for example, with no refresh rate, with VSync, you can see for 60, you can see 70 on the game counter, but your screen is displaying 60. You can see 57 on the game counter, but your screen is displaying 30. With variable refresh rate, as long as it's within those ranges, what you see on the counter in the game is what you are seeing on your screen, and that's that, period. The monitor adjusts its refresh rate to whatever the graphics card is outputting or putting out. Yeah. How do they differ, you ask? Well, if you have G-Sync, only NVIDIA GPUs will be running with it. You cannot really plug a Radeon to a G-Sync monitor and go with it. If you have a FreeSync monitor, then you are pretty much free to go, and you can use it with either AMD's or NVIDIA's graphics cards, and it will not matter. However, for FreeSync with AMD, with NVIDIA, apologies. NVIDIA is currently working on certifying non-G-Sync monitors to be G-Sync compatible. So not G-Sync certified, but G-Sync compatible. This means that they are not built specifically for G-Sync like the certified ones are, but they still work with it and still support it. If you're looking for a FreeSync monitor which is G-Sync compatible, I strongly recommend watching reviews of how it works with with NVIDIA graphics cards, because in some cases those screens experience quite pronounced issues like black screens, lines, artifacts, all sorts of things, weird refresh rates. So definitely do your research properly before trying to use variable refresh rate from a NVIDIA graphics card on a FreeSync monitor. Aside, it has to be said, like I said before, NVIDIA certified monitors are more expensive. You usually are better off going with the FreeSync route, and then you are not locked into a graphics card manufacturer either. As far as graphics cards go, like I said also, you need a better graphics card to drive the same FPS at higher resolutions. So for that matter, for 1080p, I would recommend something along the lines of 1660 Ti, maybe a 2060 if you want high refresh rates. For 1440p, I would go with a 2070 or Radeon 5700 XT. For 4K, honestly, the only option is NVIDIA with a 2080 or ideally a 2080 Ti to drive high refresh rates at that resolution. So keep in mind, the higher you go, not only the more expensive the monitor is, but the better hardware you need to actually make it run properly and smoothly. As a quick side note, it is possible, although not very common, to overclock your screen to display a higher refresh rate than it actually is capable of doing from stock. Again, any sort of overclocking has its risks, and you risk destroying your monitor, and screen overclocking is not as common and widespread as graphics card for a reason. That reason is that it is both potentially a bit more risky, not crazy, your screen is not going to explode unless you seriously push it too hard immediately. It usually starts displaying artifacts before you get to that point. But the thing is, it very often, in the majority of cases, do not see a very big return. So, it's not like your 60 hertz screen is suddenly jump up to 100 in most cases. Some cases it might get close to that, but in most cases you'll see an improvement of a couple hertz at best, like let's say from 60 to 65 refresh rate or something. So, it's usually not worth it. It's not worth voiding your warranty for a 5 hertz difference. Yeah, you can look into it. I might do a video on it in the future, but it's something that I do not really feel the need to do because the gains do not outweigh the risks. So yeah, my opinion on the whole gaming screen, I think that 144 hertz is the sweet spot, the ideal sweet spot for if you want a really nice experience. It's smooth, silky smooth. I do not own 144 hertz. I have seen and played on a few in the past though, and I can tell that there is a difference. So that is what you want to be aiming for if you have the money to buy both the hardware to drive it and the screen itself. However, I personally game on a 60 Hz monitor. For most games, it's not an issue. You will not notice a difference. You will not play worse because you are playing on a 60 Hz. You just might not have as smooth as an experience, but unless you actually try 144, you'll not notice the difference. So uh, it is up to you and to your budget what you are willing to spend on a gaming setup, if it's worth it or not. As far as resolution goes, it's the same story. Unless you really are facing yourself with a lot of money that you just want to throw away, 4K is still very expensive, both the screens and the GPUs to drive them. Unless you have a lot of money to waste on your computer, I would not even look at 4K. If you have a generous budget, 1440p 144 Hz is the way to go. If you are on the budget or if you just don't find it all that important, 60 Hz 1080p or 1440p 60 Hz is perfectly fine and it is perfectly playable. It's not like it's horrible or anything like that. Just that we're enthusiasts and we love to have the newest Chinese toys in town. This has been Addict PC Guy. I hope I have answered any questions you might have about monitors, what's what. Feel free to ask something in the comments, and hope you enjoyed it. Like and subscribe if you did. Check out our other videos about other types of content and about other technical things or gaming. And hope I'll see you next time. Have fun.